Hi everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. In this today's session we are going to deal with a curriculum called IGCSE. The subject is International Maths and the code for this subject International Maths is 0607. Okay, and this is for the ninth grade level. Okay, and the topic that I've chosen is numbers. Okay, fine. And the reference book, okay, is going to be your orders publication. Chalo. So to get started with, in this particular first chapter, or you can say the first topic, that is numbers, in this particular session, I'm going to deal with this some concepts on fractions, decimals, and recurring decimals. Okay. See, in the previous classes, in the lower classes, we know we have studied about this natural numbers, which is denoted by n, and it's a set of numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 up to infinity. Okay. Then we have set of whole numbers, which is denoted by W, a capital W. And this set consists of elements like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to infinity. Then we studied that there are some integers. Okay, we have studied about integers also. Integers are denoted by capital I or a capital Z, and integers are 0 and all the natural numbers like 1, 2, 3, 4, 5, 6 up to infinity, and all the negative natural numbers, that is -1, -2, -3, -4, -5, and it goes up to negative infinity. So here I will write negative infinity, here I'll write positive infinity, here I'll write infinity, here I'll write infinity. Fine. Okay. Now, this we have studied in our lower classes. What are natural numbers, what are whole numbers, what are integers. After integers, what happens is there is a concept called fractions that come into picture. Now, what are fractions? Fractions are numbers which are of the form n upon d. N upon d means n is known as a numerator, d is known as a denominator. Okay, the top one is known as numerator, the below one is known as denominator. For example, 2 upon 5 is a fraction where 2 is a numerator, 5 is a denominator. 1 upon 10 is a fraction, 1 is a numerator, 10 is a denominator. Okay, that way. So all these are nothing but examples of fractions. Okay, now fractions can be defined as a ratio of two integers, okay, such that the denominator is not 0. So any fraction can be defined as a ratio of two integers, but the condition is the denominator, in the denominator, the integer cannot be 0. In the numerator, it can be. What happens if the denominator is, if the 0 is there in the denominator in a fraction? If 0 is in the denominator, it makes any number or a fraction as meaningless. Okay. So in mathematics, in the denominator of a fraction, if you happen to see a 0, that number itself, that fraction itself is meaningless. It doesn't have any meaning. But on the contrary, if 0 is in the numerator, that makes some sense, and that number 0 upon anything. Okay, in the denominator you can have anything, but if there is a numerator with 0, that number will work out to, or that fraction will work out to 0 itself. Okay, so for example, 5 upon 0 is something which is meaningless. Okay, but 0 upon 5 is not meaningless, it is equal to 0. Okay, so these are the things that you should get clarified right now. Okay, now coming from these fractions, okay, to different types of fractions. Now there's something called proper fractions, there's something called improper fractions, there's something called mixed fraction. Now what are proper fractions? Proper fractions are fractions in which the numerator is less than a denominator. Okay, this is the essential condition. In improper fraction, numerator is greater than the denominator. Okay, now let us take the example of some proper fractions. 1 upon 3 is a proper fraction because 1 is less than 3, numerator less than denominator. 2 upon 5 is also a proper fraction because 2 is numerator and 5 is denominator. Okay, 25 upon 100, again it is a proper fraction because 25 being a numerator, 100 being in the denominator, and 25 is less than 100. Here you can see that the numerator are bigger than the denominator. 3 upon 2, 3 is bigger than 2. 5 upon 2, 5 is bigger than 2. 100 upon 4, 100 is bigger than 4. Okay. So whenever the numerator is bigger than the denominator, such fractions are known as improper fractions, and whenever numerator is less than denominator, they are known as proper fractions. Any proper fraction, if you work out, its answer will be less than 1. Okay, it will be greater than 0 but less than 1. And any improper fraction, if you work out, its answer will always be greater than 1. It will be more than 1. Okay, got it? Now, mixed fractions. Fractions you will get only from the improper fractions. Okay. So suppose you have some improper fraction like 5 by 2. And if you work out the division, suppose 5 upon 2, if I want to work out 5 upon 2. Okay, 5 divided by 2. So 2 twos are is 4 minus and then 1. That's it. Okay, in one step only I will decide. So this is known as the quotient. So that I will write here first. This is the remainder that I'll write here. Divided by this is the divisor that I'll write here. So quotient and remainder upon divisor. This is known as a mixed fraction. So 1 2 by 3, 3 1 by 2, 4 1 by 16. All these are examples of mixed fractions. These are of this type. Okay, quotient, remainder upon denominator. Divisor. Okay, so these numbers, these mixed fractions, you will always get from improper fractions, not from the proper fraction. Remember that. Now, next is conversion of improper fraction to mixed fraction and vice versa. So you should know how to convert an improper fraction into mixed fraction, and if a mixed fraction is given to you, how to convert it into improper fraction. So I've given you some couple of examples here. 3 upon 2. Now 3 upon 2 is nothing but a improper fraction. Why? Because 3 is bigger than 2. Numerator bigger than denominator. So it is a improper fraction. Now if I work out this 3 by 2, okay, if I do the division, see here I have done 3 upon 2, or I have not done it, but the answer is 1 by 1, 1 and a half. Okay, 3 by 2 is 1 and a half. How I got this, 3 divided by 2. 2 ones are 2. 3 minus 2 is 1. That's it. In one step only you have to do the division. Now I'll take this as the quotient, that is 1. This remainder I'll take here 1 divided by this divisor 2. So I get this answer 1 and a half. So this is known as a mixed fraction. 3 by 2 is the same as 1 and a half. Only thing is 3 by 2 is in the improper fraction form and 1 and a half is in the mixed fraction form. Second example is 5 upon 3. Now 5 upon 3 is an improper fraction. Now if you want to convert it into a mixed fraction, you just go for division. So try to divide this 5 by 3. So 5 you will keep inside and outside you will divide by 3. 3 ones are 3 minus and you get 2. So 1, 2 by 3 is the answer. So this is your mixed fraction. So this 1 and 2 are the examples where improper fraction is converted into mixed fraction. Now let us try to do this. Third problem is 4 1 by 16, which is a mixed fraction. Let us try to convert it into a improper fraction. Okay. Now what to do is you have to multiply this 4 and 16, 4 into 16, plus you have to do this 1. Okay, so 4 into 16 plus 1, the whole thing you have to divide by this divisor. Okay, this 16. So whatever answer you get, 16 fours are 64, 64 plus 1 is 65. 65 upon 16 is your answer in the improper fraction form. So whenever a mixed fraction is given to you and if you are asked to convert it into improper form, this is what you have to do. Let us try this one, fourth one, 25 1 by 3. It's a mixed fraction. So if you want to convert it into an improper fraction, 25 into 3 plus 1 you have to do. And the whole thing you have to divide by this 3. So 25 into 3 is 75. 75 plus 1 is 76. The whole thing divided by 3 will be 76 upon 3. So this happens to be a answer. Okay, this is improper fraction. Okay. Now there are certain fractions which can be further reduced. Okay. Now this is a one which can be further reduced. 76 upon 3 can be reduced. How So just try to divide this 76 by 3. So 3 2s are, you will get 6, and 7 minus 6 is 1. Then you bring down this 6, and 3 into, oh no, 3 into nothing is 16. Okay, fine. So this 76 upon 3 is a fraction which is not further reducible. Okay. So you can work out only till this. Okay, 76 upon 3. Fine. So that was about the fractions. Now let us come to decimal form. Any fraction can be converted to a decimal form. Okay, so there are proper fractions, improper fractions. So basically fraction is numerator upon denominator, and when you do the actual division and when you get the answer, the quotient in decimal form, then that number is known as a decimal number. Okay, now let us try to see some terminating fraction. Now what is the meaning of terminating fraction? Terminating fractions are those fractions which when you try to work out, okay, the remainder will always be coming as 0. Okay, so whenever there is a possibility of getting a 0 remainder, you say that that particular fraction is terminating fraction. For example, 5 upon 2. 5 upon 2, if you go for division, you will see that 5 divided by 2 will be 2 2s are 4. 5 minus 4 is 1. Then because 1 is less than 2, you bring down a 0 and you put a decimal point. And 2 5s are 10. And 10 minus 10 is 0. So you get a remainder 0. And this is the quotient 2.5. Now this quotient 2.5 that you get is corresponding to a remainder which is 0. So whenever the remainder is 0 and you get a quotient in the form of decimal form, this is known as a decimal number. So 2.5 is a decimal form of 5 by 2. So 5 by 2 is a improper fraction and 2.5 is a decimal form of this improper fraction 5 by 2. I told you improper fraction will always work out to answers greater than 1, and 5 by 2 works out to 2.5, which is greater than 1, right? Second example is 25 upon 100. Now 25 upon 100 is a proper fraction. Okay, it's not an improper fraction. Now if you divide 25 upon 100, okay, what you will do, you will do 25 upon 100. Because 100 is bigger than 25, you will put one 0 over here. So it will become 250 divided by 100. But for that you will put one 0 over here. So 0 point, right? Then we will proceed. 100 into 2 is 200. 250 minus 200 is 50. Now 50 is less than 100, so you will bring down one 0 and make it 500. And 100 into 5 will be 500. So you get 500 minus 500, 0. So here again you are getting the remainder as 0 and the quotient is 0.25. So this 0.25 is a decimal form of 25 upon 100. This 25 upon 100 is a proper fraction and 0.25 is the same value but in decimal form. Okay, so this is in the decimal form because you can see that there is a decimal point over there, and this is in the fraction form. And what fraction is this? It is a proper fraction, isn't it? So you can see that any fraction, proper or improper, can be converted into corresponding decimal form. Okay, now these are known as terminal decimals because you see that the remainder is 0. Okay, so your answer ends at 2.5, that's it. Your answer ends at 0.25, that's it. Okay, but there are certain fractions, there are certain decimal numbers which are non-terminating fractions. Now what is this non-terminating fraction? Now suppose you have a number like this, suppose you have a fraction like this, 22 upon 7. What type of a fraction is this? This is improper fraction. Why? Because numerator is greater than the denominator. So it's a improper fraction, right? Now let us try to go for division. Okay, so 22 divided by 7. 7 threes are 21. Minus karo, you will get 1. Then put a dot over here, decimal point, and bring one 0 down. Then 7 ones are 7. Then 3 is the remainder. Put one 0 and it becomes 30. So 7 fours are is 28. Subtract, you will get a 2. Again take a 0. Then 7 into 2 should be 14. Okay, 20 minus 14. So this way, if you go, you will see that you are never going to get this 0 as a remainder. Okay, so no remainder. Okay, or you can say remainder is not 0. You're not getting the remainder as 0. Okay, fine. So what happens is whenever the remainder is not 0, it's not 0, you will never ever get a 0 remainder over here. Okay, you carry on if you want this particular division and you will get tired, but you will never get this remainder as 0. Okay, So whenever you are sure that you are not going to get any remainder as a 0, such fractions, will be having a, endless number going on. Okay, so here you can see it is 3.142, but I have stopped here. But if I carry on, I'll get some numbers over here, right? Now these number, okay, is indicating that the fraction is non-terminating. Okay, by putting these dots over here, I am telling that this fraction is non-terminating. What I mean by that is the remainder is never ever going to be 0. So 3.142 dot 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 is a number which is in a form, which is in a decimal form, but this decimal form is corresponding to non-terminating fraction. Is that clear? Now, in this non-terminating fraction, you have one more category which is known as recurring. Suppose you have a fraction like 10 upon 3. Again, it is a this thing improper fraction. Okay. So let us try to do this division. 10 divided by 3. So you get 3.33 and you never get this 0 as a remainder. So you will get the answer as 3.3333. This 3 is going to be recurringly repeated. Okay, it will be repeated, for the endless time. Okay, so instead of this 3.333, I know that this 3 is going to be repeated. So I'll put a bar on that 3. Or I can do 3.3 and I can put a dot on that 3. This dot or a bar on the 3 is telling me that this 3 is going to be repeated after this decimal point. Such numbers are known as recurring decimals. Okay, so this is a recurring decimal. 10 upon 3 is 3.3 bar, or you can say 3.3 dot. Okay, 3.3 bar or 3.3 dot. These are known as recurring decimals. Okay, you can see that a particular number or a group of number will be repeated constantly after the decimal point. So these are recurring decimals or recurring fractions. Fine. Chalo. Now I have discussed about these fractions and decimals. Okay. Now let us solve some numerical problems. Okay. And let us do some preliminary exercises. Okay. So that we get ourselves booted up. Right. Now these are some numerical solved for you, and these are based on fractions. So question number 1 is arrange the fractions in the order of the size. Okay. Now when you want to arrange the fraction, it can be either ascending or it can be descending. What I mean by ascending is from smaller to a bigger fraction. Okay. Anything which is going from smaller to bigger is known as ascending, and anything which is going from bigger to smaller, okay, is known as descending. So this is descending. I hope you understand this. Okay, ascending and descending, these are the two orders. Now suppose question number 1 ka A is 7 upon 12, 1 upon 2 and 2 upon 3. These are the three fractions given to you, and the question is arrange the fractions in the order of the size. So you have to arrange them in the size. So which one is smaller, which one is bigger, which one is still bigger, that way. So you have to either show it in the increasing order, that is ascending, or you have to show it in the decreasing order, that is descending. Okay, so see how I am dealing with this question. Because these fractions, 7 upon 12, 1 upon 2, 2 upon 3, there are three fractions. All the three fractions are having different denominators, 12, 2 and 3. Okay, so first thing that I am going to do is I am going to make this denominator common. Okay, so to make the denominator common, what I'll do is I'll take the LCM of this 2, 3 and 12. So my logic is for 2 and 3 the LCM is 6. Okay, and 6 and 12 the LCM is 12. So the LCM for the entire three numbers will be 12. So LCM of 12, 2 and 3 is 12. See, if you want, I'll be making a different video, and I think I have made such videos for lower classes as well. Okay, if you go for my 7th grade ICSE videos, there I have explained all this LCM and all that concepts, right? So now I don't want to go in detail for that, but I'll tell you 12, 2 and 3, the LCM of the three number works out to 12. Once I get 12 as the LCM, what I'll do is all these three fractions, I'll convert it into a fraction where the denominator will be this 12. Okay. So 7 upon 12, I'll keep as it is because in 7 upon 12, the denominator right now itself is 12. 1 upon 2, I'll convert it the denominator into 12. So 1 upon 2 can be written as 2 into 6. To make this to 12, I'll multiply by 6. 2 into 6 will make it 12. So the numerator also I will have to multiply by 6. So 1 into 6. So this 1 upon 2 can be written as 1 into 6 upon 2 into 6, which is equal to 6 upon 12. So this 1 upon 2 is same as 6 upon 12. Same way 2 upon 3 is same as 8 upon 12. Okay. For this, what I have done is this 3 is there in the denominator. I want to make the denominator 12. So I'll multiply this 3 by 4. But if I multiply the denominator by 4, I'll have to multiply the numerator also by 4. So this works out to 2 into 4 upon 3 into 4. That is 8 upon 12. So 2 upon 3 fraction and 8 upon 12 fraction, both are equivalent. Okay. The numbers you can see are different in the numerator and denominator, but the value of those two fractions are same. They are equivalent fractions. Now, once the fractions can denominator are made common, then these fractions, 7 upon 12, 1 upon 2, and 2 upon 3, I will write it in the form where the denominators are same. So 7 upon 12, I'll write as 7 upon 12 only. 1 upon 2, I will write as 6 upon 12 because I want to write this in the form where the denominator is 12. So 6 upon 12 I'll write. And 2 upon 3, I will write it as 8 upon 12. Why? Because I want the denominator to be 12. So 2 upon 3 is nothing but 8 upon 12. So all these three fractions, I have converted into new three fractions where all the three are having the same denominator, that is 12. So that is the first step you have to do if you want to set an order. Now, since the denominators of each of these fractions is the same, that is 12, I will check what is happening in the numerator. So in the numerator, the 6 is less than 7 and 7 is less than 8. This is the order. Only the numerators I'll see. Okay, 6 is less than 7 and 7 is less than 8. 6 less than 7, 7 less than 8. Now, what I'll do is 6 के नीचे क्या है? There is 12. So 6 upon 12 less than 7 upon 12 less than 8 upon 12. I'll write this way. And this is true. So when 6 is less than 7 and 7 is less than 8, and if I divide all the three by the same number 12, still that inequality remains the same. So 6 upon 12 is less than 7 upon 12 and that is less than 8 upon 12. But 6 upon 12, we have seen that 6 upon 12 is same as 1 upon 2. So I'll rechange it. 6 upon 12 I'll write as 1 upon 2. 7 upon 12 I'll write as it is, and 8 upon 12 I'm going to write as 8 upon 12 I got from here. Okay, 2 upon 3 is as good as 8 upon 12. So this 2 upon 8 upon 12 I'll write as 2 upon 3. So I get these three fractions: 1 by 2, 7 by 12 and 2 by 3, and the order is 1 by 2 is less than 7 by 12 and 7 by 12 is less than 2 by 3. So it is in the ascending order. Okay, so this is how we have to write the fractions in ascending order. The B part of the question is 1 by 3, 17 upon 24, 5 upon 8 and 3 upon 4. Now we have four fractions. So same logic, I'll first find out the LCM of all these denominators in the four fractions. Now 4 and 8, this 4 and 8 ka LCM is 8. Okay, and 3 and 24 ka LCM is how much? 3 and 24 ka LCM is 24. Now I'll do what? I'll find the LCM of 8 and 24. And 8 and 24 ka LCM is 24. Okay, so this way I can say that the LCM of all these four numbers, 3, 24, 8 and 4, is nothing but 24. Okay, so once I get this LCM as 24, that I'll be making as a denominator for each fraction. So 1 by 3, if I want to convert it in such a way that the denominator becomes 24, 1 by 3 I will write as 3 into 8. Okay, denominator I want to make it 24. So 3 I will multiply by 8. And in the numerator also 1 I will multiply by 8. Okay, so it will work out to 8 upon 24. So this 8 upon 24 is same as 1 upon 3. But the thing is, in 8 upon 24, the denominator is now 24. 17 upon 24, I don't want to do anything because already in the denominator there is 24. 5 upon 8, now to make this denominator 24, 8 I'll multiply by 3, 8 3s are 24. But to do, when I do that, the numerator also allow to multiply by 3. So 5 into 3 I will do. So 5 into 3 is 15, 15 upon 24. This is the another fraction where the denominator is 24. Same way 3 upon 4 you can write as 3 into 6 upon 4 into 6, that is 18 upon 24. So now you can see that I have all these four fractions. Okay, which have the same denominator 24. So these fractions 1 by 3, 17 upon 24, 5 by 8 and 3 by 4 can be written as 8 upon 24, 17 upon 24, 15 upon 24 and 18 upon 24. Is that clear? Now, since all the fractions have 24 as the denominator, I will try to compare, or I'll try to arrange these numerators in order. I can see that 8 is less than 15, 15 is less than 17, and 17 is less than 18. So I've written that order. 8 is less than 15, 15 is less than 17, 17 is less than 18. Now each and every this of this number I'm going to divide by 24. So upon 24, upon 24, upon 24, upon 24. So this inequality sign does not change, it remains the same. Now 8 upon 24 is less than 15 upon 24, which is less than 17 upon 24, which is less than 18 upon 24. This is the order I get, the ascending order. But I don't want to write in this way. The question was what? 8 upon 24 I had written for 1 by 3. So I'll redo that. So 8 upon 24 I'll replace by 1 by 3. 15 upon 24 I'll replace by 5 by 8. 17 upon 24 I am keeping 17 upon 24, and 18 upon 24 I can replace by 3 by 4. So this is my answer for the fractions that was given in the question. Okay, and I have arranged it in the order. Now let us come to question number 2. Question number 2 says that find the fraction which is midway between the two fractions 2 upon 3 and 3 upon 4. So suppose two fractions are given to you, 2 upon 3 and 3 upon 4, and they have asked you find the fraction which is exactly in the midway of these two. Okay, all you have to do is you have to add these two fractions and multiply by 1 by 2. What you have to do? You have to add the two fractions and divide by 2 or multiply by 1 by 2. So I can write this as 2 by 3 plus 3 by 4 into 1 by 2. Now this 2 by 3 plus 3 by 4 I can work out. 4 2s are 8 plus 3 3s are 9 upon 3 into 4 12. 8 plus 9 upon 12 into this half. Now 8 plus 9 is 17 and 12 2s are 24. So 17 upon 24 is the answer. So 17 upon 24 is a fraction which is exactly midway of this 2 by 3 and 3 by 4. Let us do one more. 3 upon 8 and 11 upon 24. So again 3 upon 8 plus 11 upon 24 multiplied by 1 by 2. Now this works out to 8 and 24 ka LCM is 24. Okay. So 8 into 3 is 24. So that's 3. I'll multiply with this 3. So 3 3s are 9. 24 and then 24. Both are same over here. So I'll take this as 1. And 1 into 11 is 11. So this works out to 9 plus 11 upon 24 multiplied by 1 by 2. So 9 plus 11 is 20 upon 24 into 1 by 2. Now this works out to 10 by 24. And 10 by 24 can be reduced further to 5 by 12. So this is the final answer. Now let us work out this question number 3. A wooden pole is painted in 4 colors: red, yellow, blue and green. Red is covering 1/8 of the this pole. 5 upon 12 is covered by yellow color. 1 by 16 is covered by 16. What fraction of the pole is painted green? So the pole, entire pole, that is this one, is nothing but red plus yellow plus blue plus X. This X stands for the fraction painted in green. Okay. So red is given as 1 by 8, yellow is given as 5 by 12, blue is given as 1 by 16, plus this X is the unknown. Okay, what is that X? It is the fraction for green. Okay, so that you keep it as X only, and this will be equal to 1. Why 1? Because this is the pole. The entire pole has been colored in these 4 colors, right? Now what I'll do, I'll try to find out these 3 fractions. I'll have to club these 3 fractions first. 8, 12 and 16 ka LCM I'll do. 8 and 16 ka LCM is 16. And 16 and 12 ka LCM is what? 48. Right? So I'll work out this. So 48 I'll write here. 8 into 6 is 48. 6 into 1 is 6. I'll get a 6 over here. 12 into 4 is 48. 4 into 5 is 20. I'll get 20 over here. 16 into 3 is 48. That 3 multiplied by 1 they will be 3. So here I get 16 plus 20 plus 3 upon 48 plus X equal to 1. So X will be what? Now this will work out to 29 upon 48 plus X equal to 1. This will give me X equal to 1 minus 29 upon 48. This will make X equal to 48 minus 29 upon 48. That will work out to 19 upon 48. So the green part of the pole will be how much? It will be 19 upon 48. This is the fraction of the pole which is painted in green. And let us try to work out this question number 4 also. Question number 4 says that 1 upon 2 plus 1 upon 3 plus 1 upon 4 divided by 1 upon 2 into 1 upon 3 into 1 upon 4, right? So when there is an addition or subtraction of fractions, you have to use LCM. When there is multiplication of fractions, you don't use LCM. You just multiply out all the numerators and multiply out all the denominators and just reduce it in the single form. Okay. So 1 by 2 plus 1 by 3 plus 1 by 4, I will try to find out this numerator. I'll reduce it. So 2, 3 and 4 ka LCM will be 2 and 3 ka 6. 6 and 4 ka LCM is 12. So 12 will be the LCM. 12, 2 into how much is 12? 2 into 6 is 12. 6 into 1 will be 6. 3 into how much is 12? 3 into 4. 4 multiplied by 1 will be 4. 4 into how much is 12? 4 into 3 is 12. So 3 multiplied by 1 will be 3. So I get 6 plus 4 plus 3. And down in the denominator I get 1 into 1 into 1, that is 1, and this will become 2 into 3 6, 6 into 4 24. So 1 upon 24 I get. Got it? Now this will work out to 13 upon 12 multiplied by 24 upon 1. See this division I am now converting into multiplication. So denominator will get inverted. So it will become 24 upon 1. And 12 2 times is 24 and 13 2s are 26. So I get the answer as 26. Now, I suppose this is the last question. Question number 5. Copy and complete 4 by 7 minus 1 by 2 times block upon block plus 1 by 9 equal to 1 by 6. First, I'll write down this 4 upon 7 minus 1 upon 2 into this block upon block I'm taking as x plus 1 by 9 equal to 1 by 6. Now, this bracket will work out to 4 2s are 8 minus 7 1s are 7. So, 8 minus 7 divided by 7 2s are 14. So, 14 I have written here into x plus 1 by 9 equal to 1 by 6. Now 9 will come on this side, on the right hand side. So it will become 1 by 6 minus 1 by 9. And here it will become how much? 8 minus 7 is 1. So 1 upon 14x. Or you can say x upon 14. Right? Now x upon 14 will be equal to 9 minus 6 upon 9 6 are 54. So it will become 9 minus 6 upon 54, which is 3 upon 54, which is 1 upon 18. Now you will get this x as 14 will come here. So it will become x equal to 14 ones are 14 upon 18. So 14 upon 18 is what you will get as x. Now 14 upon 18 you can reduce it. If you divide by 2 you will get 14 upon 2 7, 18 upon 2 as 9. So 7 upon 9 is the answer. Okay. So that's all for today, and in the next video I'll be covering more concepts on these numbers. Okay, for example, now I'll be dealing with ratio and proportion. Also I'll be dealing with approximation, estimation, and all that I'm going to cover in different videos. Okay, so today I'm ending my video here and here itself. And if you happen to if you happen to like my video, okay, you definitely subscribe my channel, and that will help me, motivate me to make more and more such videos. Okay, so bye all of you, take care all of you, see you.